Good evening. We are moving on from where we started yesterday, or where we stopped yesterday. We are still in the topic of structure and bonding. Uh, Tell me where you're watching me from, whether you can hear me. Uh, uh, where are you? Yeah, so I would like to know where you are. Anybody who is live, talk to me. Now, there are two terms used in these particular topics, and the first one is the word structure, and the second one is bonding. Structure and bonding. Now, concerning the bonding, we've talked about very many things concerning the bonding. When it comes to bonding, we've talked of ionic bond, we've talked of covalent, and we have also talked of dative. Now, each of the bond, but remember these are cousins. I told you these ones, dative bond is a special type of covalent. But in each carbon taking place, or in each bond taking place, there must be a structure coming on. Checking on the topic for today, you can see what it means. It's talking about molecular structure. Now, molecular structure is the one that we are going to study. And molecular structure comes as a result of covalent or dative bond. Ionic bonding, we said the type of molecular that comes from here is the giant ionic structures. Giant ionic structures. Yes. So today, let's look at what we call molecular structures. Molecular structures. Yes. So now, I will start by asking you a question to name for me some of the substances that have molecular structures. We start from there. You name it for yourself, but I'm going ahead to mention them so that you see whether what you have written in your book is correct or not. So just as you're waiting for me to give you, can you name some of the substances or materials or compounds or elements that have structures called molecular structure? As I'm cleaning the board, be giving them, then I will name for you. First of all, before I name for you, most molecular structures are molecules. They do not conduct electricity. Uh-huh. They are most of them are gases and liquids, or gases or liquids. Most of them, they are gases and liquids. Now, um, give me one example of a molecular substance, or let me give you, because I've asked you very many times. It includes sulfur, sugar. Sulfur has molecular structure. Also, sugar is one of them, then iodine, and many others which you can name them. These ones have molecular structures. None of these conducts electricity. Molecular structures do not conduct electricity since they lack the required electrons and the ions to do what? To conduct electricity. Now, I have a question which I want to paste it there. Using the structure of iodine, differentiate between covalent bond and van der Waals forces. Let me paste that question on the chat section there. Yeah, using the structure of iodine, differentiate between covalent bond and van der Waals forces. We all know iodine, right? Iodine is existing as a molecule. So two atoms will form one. So utapata kuna atoms mingi imecombine to form one molecule. like I'm drawing on the board. So this is one molecule, one molecule, one molecule, one molecule, and each molecule is made up of two atoms. Now, what's going on here is between the atoms, we have covalent bond. We have covalent bond. Between the molecules, we have van der Waals forces. We have van der Waals forces. Now, so these are two atoms. So between these two, we have covalent. But between this and this, we have van der Waals. Between this and this, van der Waals forces. And because van der Waals forces are very weak, we always illustrate them using a broken or a dotted line. Ukiona kitu kama hii, that is a van der Waals forces. Unajua tena tulisemaje, covalent is a dash, dative iko na arrow. So van der Waals, because of it's very weak, it is denoted by a dotted line. Are we together, Bagabo? Yes. Now, let's look at this. If you want to break, if you supply heat to iodine, whatever you are supposed to break is the van der Waals force. That's why iodine. In fact, we cannot say iodine has a very low melting point. No. In fact, it doesn't have that melting point because, you know, we are always used to from solid to liquid to gas, ama vapor. Now, iodine will move this way directly because of van der Waals force, which when we just heat, it moves directly to gas, a process known as sublimation. And this, it also, when you cool it, it changes from gas directly to solid, a process called deposition. I hope now you are getting what I'm talking about. Let's look at some of the properties of molecular substances. Kumbuka nimeanza nikawaandikia molecular substances. So let's look at some of the processes, properties of molecular substances. Tuanze na hii. I will be pasting the question. I will be copying the question. I put it on the chat section so that we can discuss it. First of all, these molecular substances, some of them are soluble, some of them are not soluble. So the first question is, give the reasons why molecular substances are poor conductors of electricity. I'm pasting it on the chat section so that we can answer it together. Give a reason why molecular substances are poor conductors of electricity. Like sugar, sulfur, iodine. Why are they poor conductors of electricity, of heat and electricity? I will answer it. The reason is because, okay, as I think, allow me to be cleaning the board. Good. What we require for current to be conducted? We require ions or electrons. Now, molecular substances do not have ions or electrons for conduction of heat and electricity. That is the first reason. Yes. Swali number 2. Question number 2. What is the general trend in the melting and boiling point in relation to molecular masses? What is the trend? As the mass increases, what happens to the melting point and boiling point. I'm pasting another one there. So the question is, what is the general trend in the melting and boiling points in relation to the molecular masses? In short is, what happens when you increase the molecular mass of a substance like sugar, iodine? Does the boiling and melting point increases? Yes, that's the question that we're talking about. But generally, kumbuka, these substances which are molecular have very low melting point. Ukitaka, let me give you two substances that you have at home. Nyumbani, kitu moja niko sure mko nayo nyumbani, you have sugar. Sawa? Which is a molecular substance. Then we have salt. Salt chumvi, which is a sodium chloride, for example. This one has molecular structure. This one has giant ionic structure. Chukua spoon, weka sukari, pan it in the oven, it will melt. Chukua chumvi, weka kwa spoon, pan it will not melt. Why? Sugar with molecular structure has a very low melting point, but salt with the ionic structure called giant ionic structure has a very high melting point. It increases with the increase in molecular mass. Are you together? Yes. Another question. Explain the effect of hydrogen bonds on melting and boiling points of molecular substances. I'm pasting that question so that you can know what or which question I'm asking. No, let me paste it there. Good. Explain the effect of hydrogen bonds on melting and boiling points of molecular substances. Kumbuka kwanza nimesema the melting and boiling point of molecular substances increases with increase in the molecular mass. Yes. Substance like water or ice. You remember ice brings water when it is heated. The effect of hydrogen bonds, the effect of covalent bonds increases or raises the melting point of a substance. Like in water, water is made up of H2O this way. Yeah, so we have oxygen here, then ikona hydrogen, which is covalently bonded to hydrogen. Then it has weak van der Waals forces to another water molecule on the other side. So what makes water to relatively have a higher melting point is the fact that it has covalent bonds and hydrogen bonds in it. Yes. Now, let me give a definition of the term hydrogen bond. Let me give a definition of hydrogen bond. I'm copying for you hydrogen bond. Ionic bond, covalent bond. Let me put here a definition of hydrogen bond. Yes, is an intermolecular force in which the electropositive hydrogen atom of one molecule is attracted to an electronegative atom of another molecule. That is the definition of hydrogen bond. And that one you have to write them down because most of you always you skip it. So you have to write it down. Hydrogen bond is stronger than van der Waals forces, but weaker than. Hydrogen bond is stronger than van der Waals forces, but weaker than covalent bond. Good. Now, ethanol has a relatively high melting and boiling point. 78 is not something low. Why? Because it has some hydrogen bonds because of the water in it, and covalent bond because of the water in it. Yes. Now, I'm giving another question. Or in the solubility of molecular substances. Let me paste that on the chat section. Mhm. The question is, state and explain the differences in the solubility of molecular substances. Mhm. Yes, so as you're thinking about that, I will give you the answer to the same. State and explain the differences in solubility. Mm. After this, we are supposed to get what you call giant covalent structure. The other name of giant covalent structure is called giant atomic structure. Um, Most of the molecular substances like sulfur are insoluble in water. However, some of them like sugar and ethanol together with others are soluble in water. So I want you to have this. I have the list of those molecular substances which are soluble. Nimesema sulfur, I mean which are insoluble, sulfur, iodine. The ones which are soluble, I'm giving you two examples. I'm giving you sugar and ethanol. They are soluble in water. Good. So that's about molecular structure. Now, giant covalent structure. But before that, as I'm cleaning the board, I'm expecting maybe a question. Anybody with a question can ask and I answer you. And if you have a question, please paste it over there. And we stick to the class to the end. So nataka tuingie kitu ingine inaitwa giant covalent structure ama giant atomic structure. It's a very short thing, but I will explain it. The reason as to why giant atomic structure is lessly explained here is because when we get to the topic of carbon and its compound, it is fully explained. So let me see if there's anybody with a question. I can see from the side of the shifting grades, no one is having a question. On the side of the Mixled Media, no one is having a question. And on the side of Ambassador Speaks, still no one is having a question. Sawa. So let's look at the giant covalent structure. What is the name of your chemistry teacher? Chemistry teacher wako? Yeah, pia furahia. So we are looking at the giant covalent structure. It is also called giant atomic structure. So anytime umesikia giant covalent structure, wejua tu wanaongelea nini? Giant atomic structure. Are you together? And there are three substances which have giant atomic structures. I will name them here. We have number one, we have diamond. Na sio diamond yule niliwaambia jana wa Tanzania mwenye anapigana na kina Willy Pose. So we have number two, we have graphite. Then number three, we have silicon 4 oxide. So these are the substances having giant covalent structure. And in the exam, they can ask you, name the structure possessed by silicon 4 oxide, graphite, or diamond. So inategemea kama utakuwa unakumbuka giant covalent structure ama giant atomic structure. Yes. So those are the ones that they possess giant atomic structure. Now, somebody called Kimani Mbuku anasema, I want you to help me with calculation on maximum and minimum found in pressure. Sasa hiyo ni physics. Ile siku ndakuwa na chapa physics utaniambia. I will explain to you very well. Kimani Mbuku anasema chemistry teacher wake anaitwa Mr. Zero. Var CEO anasema chemistry teacher wake anaitwa Mr. Abdul Wahab. Kimani Mbuku tutapangana kwa hizo topics unaongelelea. Yes. Kuna watu wengine huku they don't know their chemistry teachers, especially these ones in the channel of Ambassador Speaks. They don't have a chemistry teacher. Si ndio? Aya, tuendelee kidogo. Now, when we talk about giant covalent structure, most of them are atoms, like diamond and graphite. You know, those ones are not compound, they are atoms. The pattern repeats itself and extends in all the directions. That's why, like, okay, well, when you look at the diamond, I don't know, okay, diamond, you can check the structure of diamond. Diamond has four, inakuwa connected na ingine huku, inakuwa connected na ingine huku. So it must be 4. Then this one connects with another 4. Goja, imetoshea hapo. Because 1, 2, 3, 4. Each one of them connects with other 4 atoms. Ukiona structure imekaa hivyo, hii pia ichikute na zingine 4. So ukiona structure imekaa hivyo, wacha nimalizie na hii pia ikutane hivi, na hii ikutane hivi. 1, 2, 3, 4, na iende hivi. So in this case, ukiona structure imekaa hivi, that is what we call a diamond. For graphite, one of them has 3. Unachukua tu moja kama hii. Ukiona ni 3, hiyo ni graphite. Ukiona ni 4, hiyo ni diamond. So in graphite, it allows 1 electron to be free. That's why graphite is a conductor and diamond is a non-conductor. Why? Because diamond uses all the 4 valence electrons in bonding, and therefore it is not a good conductor of electricity. Are we together? Diamond still. Diamond is having a giant covalent structure, atomic structure. Let me tell you 4 things about diamond. Diamond is not a good conductor of current and electricity. Why? Because in its bonding, or the bonding is done in a way that there is no electron that is free for conduction of current and electricity. Diamond is one of the hardest known elements. Maybe kuna ingine yenye sio, kuna ingine which is the most hard, but it is not known. But for the ones which are known, diamond is one of the hardest known element. Reason? Because all the bonds in diamond are strong covalent bonds with uniform arrangement. That is number 2. Number 3 about diamond, okay, kwanza, because of the hardness, the atoms are closely packed. So it has a very high density and it's very hard. Diamond has very high melting point because of still strong covalent bonds. Lastly, not even lastly, diamond, because it is very hard, it is used in making of jewelry. Sawa. Supposed to mention it, jewelry. Uongee kama mzungu, sema jewelry. Why? Because diamond is shiny. By the way, ukienda mahali upata diamond, it is shiny. So it is used in making of jewelry. Now, because diamond is hard, it is used in cutting of other metals, or cutting of metals, or cutting of substances. That is now a diamond. Graphite, on the other hand, are you ready? We move for graphite. Someone is saying my chemistry teacher is called Mr. Mohammed Amin. Sawa. Tamsalimia Mr. Mohammed Amin. Kijeshi wana nasema very late. Thank you, Kijeshi. Another chemistry teacher there. Sawa, let me see kama kuna mtu akona swali on this other side. What's the difference between diamond and graphite in terms of carbon atom? Ungesema in terms of bonding. There is no difference between diamond and graphite in terms of carbon. It is in terms of bonding. The difference is that in in diamond, all the electrons are used in bonding. In graphite, 3 electrons are used in bonding. Therefore, that is the only difference. That is the main difference. Tuko pamoja. Yeah. Now, let's look at graphite. Graphite having giant atomic structure, giant covalent structure, um, it is used as a lubricant. Why? Because its layers slide over each other when pressed. And also, when it is pressed, it slides, leaving a mark. That's why it is used in making of pencils. Graphite, um, graphite is used as a conductor, ama electrode. Why? It's a good conductor. It has one electron that is not used in bonding. Niko na swali, why is graphite? Hii mtaniandikia hapo kwa comment section. Why is graphite used as a lubricant in machines where a lot of heat is produced? Why is graphite used as a lubricant in moving parts where a lot of heat is produced? Hiyo swali umeshika vizuri. And I would like to get the answer. Why is graphite used as a lubricant in moving parts where a lot of heat is produced? I'm ready to read for you the answers, nione nani ameipata. Pia ukiogopa kuandika haina shida. Unajua kuna watu they are very coward. They don't know how to. Silicon dioxide has 4 electrons in its outermost energy level, but mostly tusiongelee silicon dioxide. Each silicon is bonded covalently to 4 oxygen atoms. Yani ukiwa na a silicon in a place like this, allow me to clean this. If this is silicon S, so it is bonded to oxygen, it is bonded to oxygen, it is bonded to oxygen, and also bonded to oxygen. Yes, but for now let's not talk so much about silicon dioxide. Now, nataka tuingie kitu kingine inaitwa metallic bonding. And hapa sasa kuna kitu watu wengi wana confusing metallic bonding. Now, this one it's not experienced in compounds. It is only experienced in metals because of what we call electrostatic force of attraction. Now, metals, examples of metals, sodium, magnesium, aluminum. Those metals on pure forms, they possess what we call metallic bond. And the metallic bond, just like they are very strong bonds. So compounds having these structures are metallic bond gives metallic structures, yes. So substances having metallic bond and metallic structures have very high melting point, like in aluminum and magnesium, because metallic bonds are very strong bonds. I said on, was it on Tuesday? I say this, anytime you ask a question on why is it having a high melting point, low melting point, boiling point, or whatever, know your answer should only lie between the type of the bond and the structure. It should not be away from that. Yes. Metallic bonding increases depending on the number of electrons. Look at this. Sodium is 281. Magnesium is 282. Aluminium is 283. Now, in all these, hata ukienda ufanye research, aluminum is having the highest melting point, followed by magnesium, and lastly, sodium. Now, these 3 is responsible for metallic bonding. This 2 is responsible for metallic bonding. This 1 is responsible for metallic bonding. There is what you call the sea of electrons, where electrons are. If it has contributed to more, it increases the strength of the bond. So aluminum has the strongest metallic bond, followed by magnesium, and lastly, sodium. The other thing that you need to know about this is all metallic bonds are conductors of heat and electricity in the two states of matter, that is, in liquid form and in solid state. A metal is a conductor in all the two states, leave alone the gas, because the metal cannot be the gas. There's a liquid, or there's a metal which is a liquid at room temperature. That liquid is mercury. Mercury is a liquid at room temperature. Yes. So that's the point. No one is having a question anymore. So let me check on that side. Because it is slippery in nature and Mbukwa is answering a question. I will come back to that question. Now, let's look at the properties of metallic bonds. Na tutaipeleka mbio mbio. Na tutamalizia hapo. So I have 5 questions which I want to ask, then we answer them very fast. So the first question is, why are metals good conductors of electricity? Because they have delocalized electrons. Hiyo hata usiwahi kuwa na issue, because they have delocalized electrons. The other name for the word delocalized is free. Free electrons. Electrons are free to be used in bonding. Explain why metals have high melting points. Because metallic bond, or they have a lot of it to break. Magnesium has a lower melting point than aluminium. Why? Magnesium is having a lower melting point than aluminium because magnesium has the metallic bonding in magnesium is not stronger as source of aluminium. Why? Because magnesium contributed 2, aluminium contributed how many? 3 to the sea of electrons where metallic bonding is taking place. Aluminium is a better conductor of electricity and heat compared to magnesium, simply because it has 3 free electrons. Magnesium has how many? 2. Yes. So we don't have much to talk about here. Hatuna maneno mingi ya kuongelelea hapa. That was structure and bonding. I think sasa tumemalizia. Na mtu akiwa na swali, you can ask me. You can ask even when you're watching a video, or when you are watching this video and you have a question. Anytime nimeweka settings on, anytime somebody has a question, my phone tells me that kuna mtu akona swali kwa YouTube. So I just answer you on there and there. Now, the other thing is this. If maybe you are requesting for some materials, still make sure that you reach us, those in the shifting grades. If you can reach the one in charge of shifting grades, you will be able to sort you out in any materials there. And for those in the Ambassador Speaks, I'm here. I will sort you out. So I will be seeing you on Monday. I will be seeing you on Monday, the same time. We shall be talking about salt preparation. Tutakuwa tukidiscuss salt. Yeah, because lazima tumalize kazi ya form 2 na form 3 before shule sifunguliwe. Yes. Kuna mtu akona swali? Na kuna swali nilikuwa nimeuliza. I can see Kimani Mbukwa is saying that it is slippery in nature and has a high melting point. I asked this question, why is graphite used in moving parts of a machine where a lot of it is produced? Because it has high melting point, the way Mbukwa has put it at the end, and Habiba Ibrahim. That is great. Anybody with a question now? We want to end there. Kuna mtu akona swali? Kama hakuna mtu akona swali, tukutane next time when we shall be talking about salts. That is on Monday. Yes. So we want now to end our session. If no one is having a question, you allow us, we end 1 minute. Aya, we are now out in 3, 2, 1. Imeondoa? Sawa sawa.
Siku hizi unamaliza mapema. Kwani mood ilienda?